we're jumping into lesson 83. I know, I just keep saying jumping, going. We're just moving right along. Let's go. Do it. Math. Multiplying numbers in scientific notation is our concept for today. And today we want to talk about how to solve this in a meaningful way. As we think about numbers, when we multiply numbers, whether they're positive or negative, right? Scientific notation means we have some sort of number. I'll just use this number. And we got zeros behind it, all right? And how to deal with those zeros. And in the past, we've always used different kinds of shortcuts to kind of just focus on our digits that have a lot of value, the 1 and the 2, and then we kind of just throw those zeros on at the end. And it's the same thing when we deal with decimals with like that, is we kind of ignore this decimal, right, when we're multiplying, and then we add this place value back in later. And it's going to be the same kind of concept that we're going to deal with now as we use scientific notation. We're going to take those different pieces and we're going to use those different pieces to solve this out. So what we're going to do is we're going to take our first part, right, the scientific part, right, and we're going to kind of group those together. And so we're going to take our 1.2 and we're going to multiply by 3 and just solve for that part right there, right? And so quick math says that, right? Then I'm going to take my powers of 10, I'm going to group those together and multiply. So 10 to the second times 10 to the fourth, which we have learned that the base stays the same, and because we're multiplying, we're now going to take our exponents, not coefficients, exponents, and we're going to add them together. So 2 plus 4 equals 6. And so in the end then, I can now join them together. So 3.6 times 10 to the 6th. And by looking at that, I got to check, first of all, is this number in scientific notation? Right? We got our first ones digit, then we have our tenths place, and we have our decimal here. So yes, it is in proper scientific notation, and we have this idea here. So we solved it correctly. Let's try it again with slightly more complex numbers. All right. Okay, this time we got a negative exponent, but for the most part, we're going to do the same thing that we did last time. I'm going to move this up here so we have not lots of space. So once again, we're going to start by grouping. We're going to group our initial numbers first. So we're going to take 2.1 times 4, not 2.4 times 4. 2.1 times 4, which we can quickly solve for this. And now we're going to take our powers. That's the word I'm looking for. So we have 10 to the negative second times 10 to the fifth. And of course our base stays the same, so I'm going to just throw that down here. And now I'm going to take negative 2 and add it to a positive 5. To a positive 5. Negative 2 plus a positive 5. So negative 2 plus a positive 5. Right? If you haven't quite mastered negative integers yet, all right, so what we need to do is we take absolute value of both. Right? Absolute value of both gives me absolute value of 2 and 5. And because they have different signs, right? We got a negative sign and a positive sign, we're going to subtract them. So technically we would want to go 5 minus 2, the bigger minus the smaller, which gives us 3. All right, so that's what we're going to put a 3 by our 10 now. And then we're going to look at our signs. We got a negative sign and a positive sign. And of course, since this had the larger absolute value, we're going to take this sign, that plus sign. So it's going to say a positive 3. It is not going to become a negative 3. But in the end, we can join our two pieces together and say 8.4 times 10 to the third for our answer. All right, if you felt that was too fast, just rewind it, watch it again, make sure it clicks. All right, now we're multiplying again. All right, here we just have just a dot here. That's a multiplication dot. Right? I could even just put my parentheses right next to each other and it'd still be multiplication. But let's try this out together. We got 7 times 3. That's easy. 7 times 3 equals 21. And then I combine 10 to the negative 4th times 10 to the negative 5th. And so my base of 10 is going to stay the same. And negative 4 plus a negative 5, signs are the same, so the sign stays the same. Add the two integers together, and I get negative 9. And so at first glance, we would say, yes, that one was easy. It's done. Not bad. However, we got to remember that we're looking for scientific notation, and this should set an instant red flag because 21 is not in scientific notation. It's still a whole number. There's no decimal in there. So before we can move on, we got to think about how does this become a decimal. And so we get 2 and 1/10, or 2.1. And so to figure out what our exponent is now, we have to understand, well, how does this number turn back into this number? How would I actually solve? What would I do to take 2.1 and turn it back into 21? And hopefully you're saying, well, I'm going to multiply 10 to the first. 10 to the first. So now I have 10 to the first that I have to put together with this 10 to the negative 9. So now I'm going to throw this in there like that. So technically this is my whole number that I'm looking at here. Right? I had 21 times 10 to the negative 9th. Now I switched to 2.1. I got 2.1 because I had to take 10 to the first, but now I also have 10 to the negative 9th. So we want to combine these two together to simplify our statement. So to simplify that statement, we're going to do the same thing we've always done. We're going to use 10 as our base, and that's going to stay the same. We're going to take our absolute values to add our powers together. Absolute value of 9 is 9. Absolute value of 1 is 1. And because they have different signs, we're going to subtract and get an answer of 8. Right? Then we're going to look at our numbers. 9 had a larger absolute value, has a negative sign, so we're going to put a negative sign in front of our 8. So in the end, our final answer is 2.1 times 10 to the negative 8th. All right, I'm talking fast, but you got plenty of video to go back, rewatch. If there's a slow motion button, do that. If not, just pause, 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 pause. See the steps, they were all there, and go ahead and solve this sample problem then as you've mastered this concept or understand this concept. If not, come with questions. If you're not sure how I did any of the steps, right now in your notes, write the question. How did you do this on example what? Or how did you do this on example 2? How did you get that negative number? Why did you have to take that 21 and turn it into 2.1? Those are questions you want to ask so that you can master this concept. That's lesson 83.